Hello all, welcome you all to AI Ki Pathshala. I am your host Anup, and today we are going to start recursion in Python. So today is the first session in recursion, and I suppose I am going to conduct three consecutive sessions on recursion. And recursion is supposed to be people understand it to be a very complex topic, but believe me, I'm going to explain you in a very mathematical and very beautiful way so that you will never able to forget the recursion in your entire life. So let's start. And those of you who are watching my recorded session, you can go to the description section of the video and join my Telegram group link so that you can get the free live classes. You can find, that's all. I'm going to share you my screen. So let me share you my screen first. And so let me start here. Is my whiteboard visible to all of you? I suppose. Everyone able to see my whiteboard? Am I get any answer from your end? Hello? Are you getting my voice?
Yes,
Yes.
sir.
Okay, so please respond. Are you able to see my whiteboard? Is my screen and audio, everything is clear to you guys?
Yes.
Fine. So let's start with recursion. Let me open my this writing pad. See, first I'm going to explain you what recursion is, what it is supposed to do, and what are the ways to understand the recursion and what type of questions we are going to do in the recursion. So first, see what is recursion. Let me open, where is this sheet for writing this? Okay, here. I get confused. Pen, this is a highlighter, this is a pen. So, recursion, I'm not at all comfortable in writing with this. So, see, whenever anyone asks what is recursion, the simple answer that most of the people give is recursion is something when the function call itself. When the function call itself, that is the recursion. Function call itself. Now, you have already understood this. We have to call function whenever I write any function and I want to perform that task which I have written inside the function, I need to call the function. So recursion is when the function call itself. But why the function call itself? I want the function to do some specific task and the function is calling itself. What it means to be calling a function? Function is calling itself. What it means to be calling function itself? So we can understand this with the help of one example, how this is all happening. Let's say, first thing, let's say I want you to calculate n factorial. This is my n factorial. So, if I want you to calculate this n factorial, what you will do? How can you calculate this n factorial? Any one of you? You must be, are you guys, first tell me, are you guys know factorial? Ruchi, do you know factorial? This factorial? Tell me, Ruchi.
Yes, yes.
I'm asking Ruchi. Ruchi, do you know this factorial? Others?
Yeah.
You know, if you do not know, please tell me. So,
I
let
know
me,
it.
okay. So let me, so tell me, what is the factorial of 5
It's
factorial?
combination something.
What is 5 factorial? Tell me what is 5 factorial.
5 into 4 into 3 into 2 into 1.
Okay. 3 into 2 into 1. This is the factorial. So you are knowing this factorial. Fine. This is good. Now let's say I have given you a question to find n factorial. So what is your answer? N minus 1
Yes.
into multiplication n minus 2
Mm.
multiplication n minus 3
-3.
so on till I reach 1 or 0. Till I reach 1. Because my this 5 factorial ends at 1.
1.
Fine. 5 into 4 into 3 into 2 into 1. It ends here. So if I will ask you to give me n factorial, you will say n minus 1 into n minus 2 into n minus 2 till 1. Now, I'm moving to the next sheet. How shall I move to the next sheet from here? Okay, add a page. So now do you guys are seeing my new screen? This is a clear screen?
Yes.
Fine. Yes. So now let's tell me one thing. So what this recursion is actually doing, let me take you what this function call is and all those things. Let me tell you. Let's suppose this is my function. Let's suppose this is my function. Function that we used to write in the Python. Just now we have discussed a lot of functions we have already. Let's say this is my function. And I am giving this function a task to calculate n factorial. I am assigning one task to this function fn to calculate the n factorial and give me the output. This is my input. This is my input to my function. And this is my output. And this is a function in between which is performing this task operation. And what is the operation that I am asking the function to perform? To calculate the n factorial. This is my operation task that I am asking this function to perform. Now see, when this function will start performing my operation n factorial, this n factorial is basically n multiplication n minus 1 factorial. Do you understand this? This, if I will ask you, calculate 5 factorial, this is basically 5 into 4 factorial. And this 4 factorial is 4 into 3 factorial. This 3 factorial is 3 into 2 factorial. And this 2 factorial is 2 into 1. And finally, what we are doing, we are multiplying all these things. 5 into this 5 into this 4 into this 3 into this 2 and into this 1. So we are getting 5 into 4 into 3 into 2 into 1. So you guys are clear till here?
Yes.
So this is the same thing. If I am asking my function to calculate n factorial, what my function is saying, I will give you n factorial. First give me n minus 1 factorial. Understand this? If I am asking my function to calculate n factorial, my function is telling me, fine, I will give you n factorial. First give me this n minus 1 factorial. Okay? So,
Yes.
till here, you understood this? Now, see, the first few examples I will take all to be very simple examples that you can solve with the iteration without using the recursion. See, whatever example I'm going to give you in some time, all those examples are very simple examples, and you can solve those questions with the help of iteration also. What is iteration? We have studied using the for loop or something kind of like that, for I in range of this. So this the solution with the help of the iteration is easier to calculate rather than recursion. Recursion solution is a little bit complex, but we are going to do that because we want to understand recursion, because there are a lot of problems which in which if you use the recursive recursion, that their solution will be very easy to write, the code is very easy to write rather than the iterative solution. If you write the iterative code, that will be very much difficult for you. That's why I am first going to solve small questions with the help of recursion. So let's write it here, like, let's take this thing right here. Let me erase it. So let's write here. This is my factorial. This is my factorial n. If I ask my function to calculate this factorial n, this function is telling me n into multiplication factorial. FACT refers to factorial, basically, not fact. Factorial n minus 1. So what it means that it is moving from a bigger thing to a smaller thing. See, I have asked a function. I have asked a function to calculate n factorial. It is asking me, okay, fine, give me factorial n minus 1. So it is moving towards a smaller input. This is my bigger input, and this is my smaller input. This is my smaller input. This is my smaller input. And this again in turn will ask me, okay, I will give you this. First, give me factorial n minus 2. N minus 2. Now, this is a smaller input than the previous input. This input that is asking, this is factorial, FACT. This is a much smaller input than this output. So as we are moving towards a smaller input. And that smaller input is easier to calculate. In this way, what actually we are doing? We are reducing the size of the problem one by one till it becomes absolutely trivial or easier. Let me write it here. In this way, let me write in a, okay, let me write it here. In this way, we are reducing the size of the problem one by one till it becomes, all these notes I will share with you. Don't worry. If you want to write, definitely you should write, but I will also share these notes with you. Till it becomes trivial. Or you can say easier. Is this thing clear to you? In this way, we are reducing the size of the problem one by one till it becomes trivial or easier. Shall we move ahead?
Yes.
Fine. So now, let me write it again here. The same thing, because we came in the factorial, this factorial n is factorial. Sorry, this factorial n is n multiplied factorial n minus 1. Fine. Now, when we reach the trivial case, trivial means smallest case or easier case, smallest case, or we will return the output. Remember this, we will understand the output, and we will not call the recursion. So this is what it is. Now, let me give you an example to understand this thing, what it means to be. Let's say I am giving you 5 factorial. So calculate, give me the 5 factorial. So what it will do, let me take a new page, that would be better. So let me give you this 5 factorial. So if I give you 5 factorial, so what you will say? Okay, fine, I will calculate this 5 factorial. First give me 4 factorial. This 4 factorial will say, fine, give me 3 factorial. This 3 factorial will say, give me 2 factorial. This will say, give me 1 factorial. This will say, give me 0 factorial. This will say, give me minus 1 factorial. This will say, give me minus 2 factorial. This will say, give me minus 3 factorial. And this keeps on going infinitely. It will keep on going infinitely. So we can't go by this way. We have to give it a base case, surface to stand. We have to give it some, we have to stop it somewhere. That point where we are stopping, actually that is called the base case. Because we cannot keep on going like that, because if we keep on going, then we will fall into the infinite loop, and our recursion will, and our this factorial will never stop, and we will fall into the trap of infinite trap. We already discussed these things before, how we can fall into the infinite trap. And we cannot go like that. Otherwise, we move to the 5 till infinity. So we will reach nowhere. So in this case, let's say 0 factorial is my base case. This is called the base case, or this is also called trivial case.
So what does this mean? We will not call the recursion.
No, what I'm telling you, see, forget about recursion right now. What I'm telling you, I am asking you to calculate this 5 factorial. When I asked you to calculate this 5 factorial, you will tell me to give me 4 factorial. Then I will calculate this 5 factorial, because you know 5 into 4 factorial. Fine.
Right, right.
And this 4 factorial will tell me to give me 3 factorial. This 3 factorial will tell me to give me 3 into 2 factorial. This
Right, right.
2 factor, let me write this for you. This 2 factorial will tell me 2 into 1 factorial. This 1
Right.
factorial will tell me to give me 1 into 0 factorial. Now this 0 factorial is telling me to give me 0 into minus 1 factorial. Fine. This minus 1
Right.
factorial is telling me to give me minus 1 into minus 2 factorial. That I have written here. This is the same thing that I have written here. So what I mean to say, if we keep on going like this, we never end. We fall into the infinite kind of thing, because it will never end. Minus 2 factorial will tell me to give me minus 3 factorial, then minus 3 factorial will give, and in this way we will keep on going, and we will reach nowhere, and we get into the trap of infinite solution. That is the solution that you will get from that will be an infinite. Fine. So that's why we need a base case or trivial cases. We also call it base case or trivial cases. So in this case, my 0 factorial is my base case or trivial case. Fine. So when I'm reaching this 0 factorial, see, this is telling me 5 factorial, telling me give me 4 factorial. This is telling me give me 3 factorial. This is telling me 2 factorial. This is telling me 1 factorial, give me, and this is telling me give me 0 factorial. When I reached here, please concentrate on 0 factorial. When I reach this here, 0 factorial, now I know my 0 factorial is equal to 1. Is this fine for you? Is this fine?
Yes.
So this 0 factorial is equal to 1. So now this 0 factorial is actually returning me 1. What this is returning me? This is returning 1. Fine. So I can put 1 here, and I can calculate 1 into 1, and I will return the same to 1 factorial. This is also 1. Thereafter, I will return this 2 into 1 is 2 to 2 factorial, and then I will return 3 into 2, that is 6, to this 3 factorial. Then this 6 into 4 is 24, and I will return that 24 to this factor, this factorial 4, and finally 5 into this 24, I am getting the output 120. Do you understood this thing or not? Please tell me. Because this is the base of understanding what I'm going to tell you after this. This thing is the basis. Ruchi, others? Ruchi?
Yes.
I'm not getting you, Ruchi, your voice. Did you went for sleeping or something?
No.
Okay. So have you
I'm unable
understood
to
this till
find
here?
the unmute button.
Okay. Have you understood this?
Yeah.
Okay. Fine. So I suppose things are clear till here. Now let's move to, first I will discuss one question. After that, I am going to discuss one concept called PMI, Principle of Mathematical Induction. So let me close my notebook and let me share my screen, and let me. Today is the 24th session or 25th session?
24.
Okay, fine. So today is the 24th and recursion we are going to discuss. So let's take one question, same question that I have discussed right now. The same question I'm going to solve with the help of recursion. So let's first take an input. Okay, first take factorial. Oh, sorry. Def factorial and take n. And to calculate the factorial of n, what you need? Return n into n into factorial n minus 1. Is this the same thing that I have discussed right now? This is my function. I have written one function called factorial, this fact function, it refers to factorial. And I passed n as an argument. And I asked the function to return me n multiplication factorial of n minus 1. What it means? Now this factorial n minus 1 in fact will ask me to return n minus 1 into factorial n minus 2. That in turn will ask me to return n minus 2 into factorial n minus 3, and it will goes on till it reaches a base case. Do you understood this? Now let's take an input from the user. Let's take input from the user integer. So I am running this code first, then let's call here. First take the input from the user and then call this function, and let's call this function. Let's take the input. Okay, I have what okay, so let's take the input. Okay, making the mistakes. So interrupt. So I have given 5 as an input, and let's see what happened. What is the wrong thing that I am doing here? Will any one of you able to point it out? What is the wrong thing that I am doing here? I have done it intentionally to make you understand what is the wrong thing that I am doing here. See, what error I am getting here? Maximum recursion depth exceeded. See, there is a limit to the depth of the recursion, but this Python will go on. Why? And this depth is approximately, I suppose, 1000 approximately, and sometimes it varies from system to system also. In my system, it is approximately 1500 something, like 1558 kind of. and it may vary in your system, but approximately it's 1000, and you can even change their depth. So as soon as the recursion will reach the maximum depth, which is fixed by a system, which is fixed by default, it will give me the error. So why it is giving me error? What is the fault? What is the wrong thing that I'm doing here? This function is actually falling into the infinite thing. Why? Because I have not given it a base case, my trivial cases. It simply keeps on going. Just like I have told you, if let's say I have, this is the same thing, I have asked you to calculate 5 factorial, and what you are telling me, 5 into 4 factorial, this is giving me 4 into 3 factorial, this is giving me 3 into 2 factorial, this is giving me 2 into 1 factorial, this is giving...
Hello,
Yes,
I'm not getting your voice. I'm not getting your voice.
you are not getting my
I'm
voice?
not getting your voice.
Okay. Is everyone else getting my voice?
I'm not getting your voice.
Okay, let me check it. So, Mr. Misra, are you getting my voice
Yes, yes,
clearly?
yes.
Others, are you getting my voice?
Yes.
Ruchi, everyone else is getting my voice clearly. So, I suppose maybe there is a issue to get your voice. Please check your mic. Please check. Please try to connect again. Connect again. Ruchi, please try to connect again. Everyone else is getting my voice clearly. Only you are getting the problem. So maybe the problem is from your end. Please try to connect again. That will be better for you. So see, some of you get disconnected. That's why I'm repeating it again. See, what happened when I have called this function factorial, and in the place of n, I have supplied it 5. I'm getting this error, and this error is maximum recursion depth exceeded. So there is a limit to the depth of the recursion depth which it can goes. So usually this limit is approximately around 1000. In my system, it's around by default, it is set to like 1500, some 58. And but most of you will get the recursion depth of around 1000. So as soon as it will reach that depth, it will stop execution. Why it will stop execution? Because the recursion consumes lot of memory. Whatever function is running behind it contains, it is actually consuming lot of memory. So if, and your system is not having an infinite memory, it has a limited capacity of the memory. Your RAM is having a limited memory. That's why it is giving me an error. So it is set in that way, it is programmed in that way that it will automatically stop after reaching the maximum depth. Fine. You can change the depth of the recursion. It's in your hand. You can set it to different depth, but by default, it is set to around 1000. So what actually it is happening, you can understand this by taking this example. So what I have asked, calculate 5 factorial. It is telling me to calculate 5 into 4 factorial. This 4 factorial is telling me to calculate 4 into 3 factorial. This 3 factorial is telling me to calculate 3 into 2 factorial. This 2 is 2 into 1. 1 factorial is telling me to calculate 1 into 0 factorial. This 0 factorial is telling me to calculate 0 into minus 1 factorial. This minus 1 factorial is telling me to calculate minus 1 into 2 factorial, minus 2 factorial. This minus 2 is telling me to calculate minus 2 into minus 3 factorial. And this will keep on going infinite. Why it is keeping on going? Because we have not given here my base case. I have not asked my recursion where it needs to stop and return me something. That's why it is giving me error, because it fall into the infinite, not iteration, infinite factorial, because it keep on calling and it never stopped. And when it reached the maximum depth, it gave me the error. So now to avoid this kind of thing, we have to give it a base case. So let's understand this. What is this base case and how we can give the base case? See. See. I am writing this for you. By default, Python has 1000 depths for recursion. Fine. Now, I am writing the same program here, but this time what I will do, I will give it a base case. So, let me give it a base case. So, what is my base case? If n is equal to 0, this is my base case. This is my base case for recursion, and return 1. So now what I'm asking, I'm giving it a base case. When n will reach 0, return me 1. Now if I run it again, now let's see if I run this program again, and if I call my function 5, it will give me the correct output. In the same thing, here I was not giving it a base case, so it is giving me actually it is giving me error when I was calling that function. But here, since I have supplied it here a base case, now it is not giving me any error. Why it is not giving me error? Let's understand this with the help of same 5 factorial. See, I have asked my program to calculate this 5 factorial. My program has told me, okay, fine. Give me this 4 factorial first. Then this 4 factorial has told me to give me this 3 factorial. This 3 factorial has asked me to give me this 3 into 2 factorial. This 2 factorial has asked me to give me this 2 into 1 factorial. And this 1 factorial has asked me to give me 1 into 0 factorial. Fine. Now, when n is equal to 5, now it will keep on checking. If n is equal to 0, is n is equal to 0? First, if I will supply it with 5. So what it is checking? It will check. If n is equal to 0, no, n is not equal to 0. It is false. So it will not go inside this. It will not go to inside it. It will come here, and what it will return? It will return this 5 into 4 factorial. This n is 5. And this factorial n minus 1 is 4 factorial. So it has returned me this. Is this thing clear to you or not? Please tell me. This by first step. Ruchi,
No, please explain it again.
what?
This one. By default, Python is 1000 depth. After what you know, then I'm not even.
Okay, just forget it. I will explain you later. Tell me, do you able to understand this thing or not?
No, I'm not able to understand.
Do you able to understood? Okay. Do you able to understand this or not? This first?
Yes. Yes.
Okay,
Yeah.
fine. So see, what I'm telling, when I have run this program, what happened? This factorial n factorial is, let's you have given it 5, so it give me the error. Why it is giving me error, that I have explained. Oh. So let me explain you once again. So
That much I've understood, that we have not provided the base value, that's why it's
okay,
giving us error. That much I've understood. But the further thing I'm not able to listen.
okay. So this depth, see, there is a depth till which the recursion can go inside the Python. That depth is set to 1000 depth for recursion. This is not a, this is a simply, you will understand this when I will give you some few more examples. So this is the depth. This is my first depth. This is my second depth. This is my third depth. This is my fourth depth. This is my fifth depth. Do you understand this? This is how
Yeah.
till 1000 depth I'm asking, I'm telling you. Do you understand this? When I'm going to calculate this 5 factorial, this 5 into 4 factorial, this step is my first depth. Then 4 into 3 factorial, this is my second depth. 3 into 2 factorial is my third depth. 2 into 1 factorial is my fourth depth. And it will goes on till 1000 depth. If you reach 1000 depth, if you exceed, maximum depth allowed is 1000. If you exceed that, it will throw you an error. Do you understand this?
Okay.
And this is a
Yeah.
default set by the Python. You can increase the depth as per, if you need, you can also increase the depth. Now, in this question, second question, this factorial, and I have defined one base case, that because why I was getting this, I was fallen into this infinite thing, because I have not supplied it a base case. So here I have supplied it a base case. Is it okay? That base case is n is equal to 0. What I'm asking, when I reach n is equal to 0, return me 1. That is what this factorial thing is about. 5 into 4 into 3 into 2 into 1 into 0. Now this 0 factorial is 1. So this 0 factorial is returning what? 1. Is it fine?
Yeah.
Now, whatever I'm going to explain you, let's understand this. See.
Okay, I got it. How it got down to the 120.
So fine, you got it. Now let's understand something more. So when I have given it 5 here, when I have given it 5, this factorial, when I'm calling this function that I have written here, this function that I have written here, I'm calling this function here. So I have given 5 here. In the argument, I have given 5. So now this 5 factorial. So it is checking. This is coming here, and if n is equal to 0, is 5 is equal to 0? Tell me, yes or no?
No.
What?
5 is equal to 0?
Is 5 is equal to 0? No.
No.
That
That's what I
means,
said.
that means it is false. This
Yeah.
condition will become, and it will not come here. So where
No.
it will go? It will come here.
Huh.
So now what this is telling? Return n into factorial n minus 1. What is my n?
5.
So I am getting 5 here. See.
Yeah.
What is my factorial n minus 1?
4.
Not 4. 4
4
factorial.
factorial.
So I am
4
getting
factorial.
this 4 factorial here.
Yeah.
And this is, let's say, this is my first step, or this is my depth one. I am writing here.
Okay.
Now see. Now see what will happen. Now come here.
Again,
This
base
4
case.
factorial, it will check, is n is equal to 0?
No.
So what it is going to return? This 4 into
And
4 minus
into
1, 3 factorial.
factorial.
This thing. 4 and 4 minus 1 is 3 factorial. Again, same will happen.
Yeah.
So what it is going to give me? This 3 factorial, this 3 and this 2 factorial. Again, it will check this 2 is equal to 0. No. So it will give me 2 and 1 factorial. Again, what will happen? This 1, it will check, is n is equal to 0? No. Again, 1 into 0 factorial. Do you understand till here? Now, when it reaches this 0 factorial, this is very important. See, when it reaches this 0 factorial, now it is again checking. 0 factorial, when it reaches this 0 factorial, so now what is the value of n? This time 0.
0.
Now it is checking, is n is equal to 0? Yes.
Yes. So it will return
it should
1.
return me. What it should return me?
1.
Return me 1. So this 0 factorial is returning me what? 1.
1.
So what is the value here? 1. So this 1 into 1 will give me what? How much value? 1.
1.
And this entire thing is returning to this thing, 1 factorial. So what I am returning to this 1 factorial? 1.
Yeah.
Now this 1 factorial is returned, I am returning 1 to this 1 factorial. That means the value of this 1 factorial is 1. Now this entire thing is returning to this 2 factorial.
2.
What this is returning? 2 into 1 is 2.
2.
So this entire thing is returning 2 to this 2 factorial.
Yeah.
Fine. And now this 2 factorial is 2. Because
Yeah.
I got returned from this. And now this 3 into 2 is 6. So this entire thing is returning how much? Returning 6 to this 3 factorial. Now this 4 into this 6 is 24. So this entire is returning how much? 24 to this 4 factorial.
24.
And this 5 into 24
is 120.
120. So this is returning to this 5 factorial. So finally what I am getting? 120. Do you understood this or not? All of you guys.
Yes.
Because this is the basis of what I am
Yes, understood.
explain you next thing. That's why I am very much serious about teaching you this time and again with the help of the same example. Mr. Misra sir, have you understood this or not?
Yes, yes.
Fine. Okay. So this was a very easy thing. So now let me explain you few more things here. So let me first clear me my screen and let's find factorial of, let's say, 6. In the same way it is going to calculate this. If you find factorial of, let's say, 10, you will get these results. Now Next thing that I am going to explain you is the principle of mathematical induction. So before, let's stop sharing my screen. So before I make you understood this thing, it's time for a, I suppose, a joke time. So any one of you want to crack few jokes, you can crack. Others, आप हिंदी में, इंग्लिश में, किसी में भी, जिसमें भी मर्जी हो, किसी और भाषा में भी तो आप जो क्रैक कर सकते हैं.
No, currently I don't have any joke.
Okay, you रुचि?
Same. I'm eager to listen your joke.
Okay, fine. So, okay, fine. तो मैं एक जोक सुनाता हूँ आप लोग को, थोड़ा सा मूड को लाइट कर ले, फिर करेंगे. तो ये हुआ कि मुल्ला नसरुद्दीन का मन किया कि डॉक्टर बन जाऊं. तो बच्चा बचपन से ही पढ़ाई लिखाई करना शुरू किया और वो एमबीबीएस गैनोकोलॉजिस्ट बन गया. वो गैनकोलॉजिस्ट आप लोग समझते हैं?
Yes.
ठीक है, तो वो गैनकोलॉजिस्ट बन गया. तो एक दिन वो अपना प्रैक्टिस करता था. एक दिन रात को 1 बजे एक परिवार से उसके एक मित्र का फोन आया जिसकी वाइफ प्रेग्नेंट थी. तो उसकी वाइफ को अचानक से रात को 1 बजे बहुत पेन स्टार्ट हो गया. तो उसने, अब उस समय आंधी तूफान चल रही थी, बारिश भी हो रहा था, मौसम बहुत खराब था, हॉस्पिटल भी नहीं ले जा सकते थे और आसपास कोई हॉस्पिटल भी नहीं था. तो उसने मिला दिया फोन मुल्ला नसरुद्दीन को कि अरे नसरुद्दीन साहब, डॉक्टर साहब, ऐसे ऐसे मेरी वाइफ को पेन स्टार्ट हो गया एंड बेबी होने वाला है, तो आप जल्दी से आ जाइए. अब नसरुद्दीन क्या करे, उतनी रात में, एक तो आधी नींद में था बेचारा. वो उठा, किसी तरह अपना झोला वोला लिया, जो भी उसके पास उस समय इंस्ट्रूमेंट्स हुआ करते थे. ये थोड़ी पुराने जमाने की बात है, ये आज की बात नहीं है, ये लेट से 25 साल 50 साल पुरानी बात होगी. और फिर वो किसी तरह धक्का देके अपनी गाड़ी को स्टार्ट किया. गाड़ी भी स्टार्ट नहीं हो रही थी. बैठा, टॉर्च वॉर्च लिया, सब लिया और निकल गया. और बड़ी मुश्किल से वो उसके घर पहुंचा. जैसे पहुंचा तो उसकी वाइफ पेन से एकदम कड़ा रही थी, जोर जोर से चिल्ला चिल्ला के रो रही थी. ऑब्वियसली पेन होता है तो लोग ऐसे करते हैं. अब उसने बोला कि ठीक है, तो मुझे ले चलो, कहाँ है तुम्हारी वाइफ. उसने ले गया उसकी वाइफ के रूम में. तो जो वाइफ के हस्बैंड थे वो बाहर, रूम के बाहर खड़े थे कि चलो अब डॉक्टर साहब आ गए हैं तो आगे की प्रक्रिया अब डॉक्टर साहब करेंगे, नसरुद्दीन साहब करेंगे, मुल्ला मुल्ला नसरुद्दीन करेंगे. और तभी मुल्ला नसरुद्दीन अपने दोस्त उसको बुलाया, इधर आओ. बोला क्या हुआ? तो मुझे एक हथौड़ा चाहिए, जल्दी से मुझे हथौड़ा दो. वो घबराया, यार हथौड़ा की क्या जरूरत है, ये डॉक्टर है, इसको दवाई देना है, जांचें करना है. तो फिर भी सोचा चल ठीक है, ही ट्रस्ट हिम, वो विश्वास करता था उसके ऊपर, नसरुद्दीन के ऊपर. तो उसने एक हथौड़ा ला के दिया और फिर वो अपना बाहर खड़ा हो गया, बाल मतलब रूम से बाहर खड़ा हो गया, लेट से कॉरिडोर में खड़ा हो गया. अब उसे अंदर से आवाज आ रही है, ठक 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 ठक, ठोक पीटा पीट पीट की आवाज आ रही है. और उसकी वाइफ अलग चिल्ला रही है, उसको पेन हो रहा है तो वो चिल्लाएगी. अब इसका दिमाग खराब हो रहा है बाहर खड़ा होके कॉरिडोर में कि ये क्या चल रहा है अंदर भाई, ये कहीं मेरी वाइफ को हथौड़ा तो नहीं मार रहा है. तो फिर फिर वो बाहर निकल के आया थोड़ी देर में. बोलता है एक मुझे खंती ला के दो, ये हथौड़े से काम नहीं होगा, खंती ला के दो. अब इसका दिमाग तो थोड़ा सनक रहा है, लेकिन अब करे भी तो करे क्या. अब अभी मुल्ला नसरुद्दीन से पंगा भी नहीं लग सकता है, मुसीबत में था और दोस्त भी था तो विश्वास भी करता था. तो किसी भरे मन से वो गया, खंती वंती लेके आया. खंती इट मीन्स बड़ा सा एक रॉड, लोहा का, that is used to plow the field. तो वो किसी तरह लेके आया, दे दिया बेचारा, दिल पे एकदम वो रख के वो लेके गया मुल्ला नसरुद्दीन अंदर। फिर अंदर से जोर जोर से आवाज आ रही है, ध्राम ध्रूम 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 करके आवाज आ रही है। और उसकी वाइफ और जोर से करा रही है, क्योंकि उसका पेन बढ़ रहा था टाइम टू टाइम। अब इसको बर्दाश्त नहीं हो रहा है कि यार हो क्या रहा है, अंदर चल क्या रहा है, ये कहीं कुछ अनहोनी तो नहीं हो रहा है, कहीं कुछ ये मुल्ला नसरुद्दीन कहीं ये वेटरनरी डॉक्टर तो नहीं है, कि जानवरों का इलाज करने वाला डॉक्टर तो नहीं है ये, गलती से इसको मैं बुला लिया हूँ। अब ये सोच में पड़ा हुआ है, तभी वो मुल्ला नसरुद्दीन वापस आया अंदर से, ठीक है, वो भाग के आया, बोला सुनो यार तुम, इससे नहीं होगा, तुम एक काम करो, एक बड़ा पत्थर लेके आ जाओ, डेट विल डू इट, डू दी वर्क, पत्थर लेके आ जाओ, एक बड़ा सा चट्टान लेके आ जाओ। अब ये बोला, अब इस अब ये अपना आपा खो दिया, पेशेंस लूज कर दिया। ये बोला अरे भाई पत्थर लेके क्या करोगे, कुचल दोगे क्या मेरी वाइफ को? अरे मुल्ला नसरुद्दीन बोलता भाई तुम्हारी वाइफ तक तो बात ही नहीं पहुंची है, पहले मेरी पेटी तो खुल जाए, हथौड़े से नहीं खुली, खंती से नहीं खुली, अब मैं पत्थर से उसको तोड़ ही दूंगा। भाई मेरी पेटी खुलेगी तभी तो मैं अपना आला वाला निकालूंगा, दवाई ववाई निकालूंगा, अपना इक्विपमेंट्स निकालूंगा, लगाऊंगा। तो अभी तो वहां तक बात ही नहीं पहुंची है, जल्दी से अब तोड़ देते हैं, और कोई कोई कुछ नहीं बचा अब। तो दिस इज द जोक, खत्म हो गया।
बहुत अच्छे।
नाइस जोक।
अच्छा एक और सुनाओ,
एकदम एकदम।
एक और सुनना है आप लोग को?
हाँ हाँ हाँ।
ठीक है। तो
हाँ।
इस बार क्या हुआ कि मुल्ला नसरुद्दीन एक कहीं साइड पे जा रहे थे, तो नहीं नहीं सॉरी, मुल्ला नसरुद्दीन से एक बार कोई मिलने आया। तो वो जो मिलने आया था वो क्या था, वो बहुत बड़ा शिकारी था। तो मुल्ला नसरुद्दीन को बड़ी बड़ी बातें करने का आदत था, कि बड़ी बड़ी छोड़ने का। तो उसने बोला कि देखो मैं तो शिकार अलग तरीके से करता हूँ। तो बोला कि कैसे? तो बोला कि देखो जैसे अगर मुझे हिरन का शिकार करना होता है तो मैं एक अलग तरीके का आवाज निकालता हूँ, तो हिरन की झुंड मेरी तरफ अट्रैक्ट होके आ जाती है वो आवाज सुन के, और फिर मैं शिकार कर लेता हूँ आसानी से। जब मुझे किसी लोमड़ी का शिकार करना होता है तो मैं लोमड़ी का आवाज नहीं, एक दूसरे तरीके का आवाज निकाल लेता हूँ, उससे लोमड़ी आ जाती है। ऐसे करके मैं जिस भी जानवर का मेरे को शिकार करने का मन होता है, हिरन का शिकार करने होता है या किसी का भी शिकार करना होता है, तो मैं उस एक यूनिक आवाज निकालता हूँ उनके लिए, और उस आवाज से वो लोग अट्रैक्ट होके आ जाते हैं। तो बोला अच्छा। तो उसने बोला कि अच्छा अगर तुम्हें शेरनी का शिकार करना हो तो तुम कैसी आवाज निकालते हो, एक बार मुझे निकाल के दिखाओ। बोला ये तो यार बड़ा मुश्किल काम है यार, शेरनी का शिकार करने के लिए आवाज निकालने के लिए कैसे निकालूं? बोले ठीक है, अब जब तुम बोल ही दियो तो निकाल देते हैं। तो उसने एक विचित्र तरह का आवाज निकाला, बोला कि अगर तुमने ये आवाज निकाली तो क्या शेरनी आ जाएगी? तो बोला बिल्कुल आएगी, देख लो। तो उसने एक विचित्र तरह का आवाज निकाला। जैसे उसका आवाज निकला कि सामने से गेट खुलता है और वहां से निकल के आती है मुल्ला नसरुद्दीन की बीबी। बोलती है बहुत देख रही हूं तुमको, आज सुबह से तुम हल्ला गुल्ला किए जा रहे हो, आज ज्यादा करोगे तो मैं कच्चा निकल जाऊंगी तुमको, ये सब बंद करो नाटक और शांति से निकल जाओ घर से। नहीं आया समझ?
आया आया। नहीं, आ गया आ गया।
नहीं आया समझ?
आ गया, समझ आ गया।
रुचि आपको आया?
हाँ।
ठीक है, अब लगता है कि हम लोग का एंटरटेनमेंट हो गया, तो अब हम लोग
भैया
कंटिन्यू।
मुझे भी जोक सुनाओ भाई।
हाँ ठीक है, अभी अब लास्ट में सुनाएंगे, चलो
ठीक है
ठीक है।
ठीक है।
ठीक है, तो अभी हम लोग शेयर करते हैं व्हाइट बोर्ड, और हम लोग शुरू करते हैं। Let's start. So, what we are going to study? Is this which whiteboard I have opened? Whiteboard Zoom. There. This whiteboard. Okay. So I suppose the whiteboard is visible to all of you. Now let's understand very important concept that I am going to discuss with you. This is called, I want to explain you what is the math behind this recursion. You are going to understand this thing. Maths. Okay, यार ये रेड क्यों select हुई है? So how I shall remove this? Okay, fine, not an issue. Maths behind recursion. So let's understand the maths behind recursion. So you must have studied about, there is one concept called PMI. What this is? This is called Principle of Mathematical Induction. Mathematical Induction. So do you guys are aware of this thing, Principle of Mathematical Induction? This is concept I suppose we have studied in maybe in class 9th or 10th or maybe 8th, 9th, 10th, something like that. So this is used to prove lot of theorems, concepts and all those things. So we are going to discuss the principle of mathematical induction. So let's first understand how we use the principle of mathematical induction. We'll take first one example to understand this. Let's suppose I'm asking you to calculate the sum of first n natural number. Using this PMI. So you have to calculate the sum of the first n natural number using this PMI. First thing is that we know from this formula, you must be knowing that the sum of the first n natural number is equal to n into n plus 1 by 2. Is this thing clear? Do you know this formula, everyone?
Yes. Yeah.
Sum of the first n natural number is n into n plus 1 by 2. Move to the next page. Are you seeing my fresh screen?
Yes.
Is my blank screen visible to you guys? So
Yes.
So how the principle of mathematical induction work? It's like, let's say, if I want to prove that sum of the first and natural number, okay, let's take one statement called, let's take this statement. This is not working. Okay. So let's take this statement. This is my statement. Let's say F. I am giving the name statement as F. And let's suppose F is true for all natural number. Natural number. So this is my statement F. This F is true for all natural number. Now, to prove that this sum of the first natural number, summation of n is equal to n into n plus 1 by 2, what I need to do? So this PMI says, what this PMI says, Principle of Mathematical Induction says, it says, first, prove for f of 0 or f of 1 or both means f of 0 or f of 1, both is true. So whatever statement, whatever thing, summation, let's say summation of n is equal to n into n plus 1, I have to prove this. This is true or not. So with the help of PMI, what PMI says, first thing that PMI says is, first prove for f of 0, then prove that f of 1 or both is true. This is my first thing that PMI says. Here, f of 0 or f of 1 means that we are taking very small number, or we are taking very small number. We are taking very small number. And I want to prove it for that small number. So my first task in PMI, wherever I will use PMI, Principle of Mathematical Induction, my first task 1, is to prove f of 0, comma f of 1 or both is true. This is my first task. After that, there comes the assumption part. When I prove this, then the second thing is that PMI says is assume. F of k is true. F of k is true. And one very important thing, this is an assumption. You do not question this. You do not question this. So till here, do you understand? First thing that I will do, f of 0, f0 of 1 is true. Second, I will assume that f of k is true. And this is my assumption. We don't need to worry about this. We don't have to think it in a very logical manner. This is just an assumption. And you do not need to question this assumption. You have to just assume this, that if this is true, and then you will assume that if f of 0 or f of 1 is true, then assume that f of k is true. This is how the PMI works. Now, is my third screen visible, new screen visible to you? Guys?
Yes.
Now, there comes the task 2. PMI says, prove f of k plus 1 is true. So first thing that PMI says, that assume f of 0 or f of 1 proves first or is true, not assume. Task 1 is to do f of 0 or f of 1, then you have to assume f of k is true. Thereafter, task 2 is to prove f of k plus 1 is true. So let's apply the principle of mathematical induction on this thing. Sum of first n natural number is n into n plus 1 by 2. And let's see how sum of first n natural number, Sn, I am giving it a name, first n natural number, how the principle of mathematical induction is working here. So let's take first task 1. So let's assume this is my function f and this is my function fn. So what is my first case? F of 1 or f of 0 is true. So let's consider this. What is this? This is summation of 1, and this is summation of 1 is 1 into 1 plus 1 by 2. This is equal to 2 by 2. This is equal to 1. Is this thing clear? And this is my base case. This is my base case. So my base case is proved. How my base case is proved? My base case is proved because I have considered summation of 1. I know that summation of 1 is equal to 1. Now, this I have applied this formula, n into n plus 1 by 2. N is 1 into n plus 1, 1 plus 1 by 2. I get 2 by 2 is equal to 1. So this LHS is equal to RHS. So my base case is proved that f of 1 is true. Is this thing okay to you?
Yes.
Now, my second thing is, since I have proved the base case, now my second thing is, assume f of k is true. That is my second thing, f of k is true. This is my assumption. I did not need to question this. So what is my second thing? Summation of k. Summation of k is k into k plus 1 by 2 is true. This is true. This is my assumption. So this is true. Now, after I assume this, my task is, second task is, using the base case and the assumption that I have made, prove summation of k plus 1 is true. is true. I have to prove this. This is, I have to prove this. I have to prove this. And to prove this, I have to assume that summation of k is true. Now, let's see what is the summation of k plus 1. Summation of k plus 1 is k plus 1 into k plus 1 plus 1 by 2. This is the summation of k plus 1, na? See, let me write it here. Assumption. And this is to prove. What is my assumption? I have assumed summation of 1 is equal to true. This comes out to be 1 by 1 into 2 by 2. So this comes out to be true. So this I have already proved. Then I have what I have assumed. Assume summation of k is equal to k into k plus 1 is true. And now what I have to prove? I have to prove this thing, summation of k plus 1. This is k plus 1 by k plus 2 by 2. I have to prove this. So see, summation of k plus 1 is what? What is summation of k plus 1? Summation of k plus 1 is, if you want to write it, you can write it like summation of k plus 1 is k plus 1 okay, not this. Okay. Summation of, let me take it in next page so that it will be summation of k plus 1. You can write it as summation of k plus 1. Do you understand this? You guys please tell me, do you understood this thing? Summation of k plus 1, can I write it in this way? Summation of k plus 1?
Yes, just a minute.
Ruchi, you? Ruchi?
Yes, sir. Yes, I got it.
Others?
Yes.
Fine. So if summation, okay. Misra sir, have you got it? It is simply like, let's see, Misra sir, let's see, 1 plus 2 plus 3 plus 4 plus 5. So let's say this is summation of, this is k and this is k plus 1. Let's see, this is k and this is k plus 1. That I have asked. If I will ask you to write summation of k plus 1, can you write it like k plus, summation of k plus k plus 1? This thing plus this thing. Misra sir? Misra,
Yes,
can you write it like this? I have given you an example. Let's say 1 plus 2 plus 3 plus 4 plus 5 is this.
yes.
Let's suppose this is k, 1, 2, 3, 4, and this is k plus 1. K plus 1 is 4 plus 1, 5.
Okay.
So if this is, this entire thing, 1 to 5 is k plus 1.
Hmm.
Can you write it like this is my here to here k, and this is my k plus 1. Can I write it like summation of k, summation till here
Yes,
plus
I
k
can write.
plus 1? This thing.
Yes, I can write.
Can you got it? Okay, fine.
Yes.
So this is what I have written it here. This is what I have written it here. So see what, okay. So see what it means that now I know summation of k is k into k plus 1 by 2, and this summation of, or this k plus 1, can I write it like, I multiply numerator by 2 and then divide it denominator by 2? Can I write it like this?
Yes.
Ruchi, can I write it like this?
Yes.
Now, if I will just take k plus 1 by 2 as a common, then we will get what I will get. K plus 1, if I will by 2, I will get k plus 2 here. Finally, what it is? K plus 1 by k plus 2 by 2. Now see what was my LHS and what was my RHS. If you will come to this space, see, I have to prove this thing, that this was my RHS, right hand side, and I have taken this LHS and I have proved that my LHS is equal to my RHS. You got this?
No.
No?
Yes, yes.
Okay. So finally we have
How we
arrived. Yeah.
get to here?
See.
Okay, fine. First we have multiplied.
Yes, yes. We have multiplied both numerator and divided by 2, and then I have taken. So I have proved that LHS is equal to RHS. This I have taken one example to demonstrate you the working principle of PMI, Principle of Mathematical Induction. Now we are going to use the concept of PMI in all the questions of recursion that we are going to discuss now. We are going to use the same principle of mathematical induction. So basically what we are doing here, see, it is not a baseless. We are taking one base here and we are taking a base case and take, let's say 1, and thereafter we are considering this base case, we are proving this thing. Considering this thing, we are proving, let's say this thing, and it keeps on moving. And I have taken a generic value of k. I have taken a generic k. I have taken a generic k. Fine. Finally, I want to tell you something. The assumption that PMI says is called induction hypothesis. Induction hypothesis. This is called induction hypothesis. Now, three things I am going to conclude you now, all those things that we have discussed. F of 0, let's say this is, and this is f of n minus 1, and this is f of n. So what you have to remember, you have to consider three things. Whenever you are going to solve any recursion question with the help of PMI, you have to take care of three things. Finally, what is this three things? First thing, what is my, this is the most important thing, what is my base case? So whatever problem of recursion you will consider, first thing that you have to consider is your base case. Last time I have considered my base case as 0 or 1. Second thing, what is my hypothesis? What is my hypothesis? Hypothesis. What is my hypothesis means? What is my assumption? What thing I am going to assume? And third thing, what is the induction step? Induction step I need to take. These are the three most important things that you have to consider whenever you are using the principle of mathematical induction. I suppose, what is the time? So we are already exceeded the time limit. So I suppose now we cannot discuss the questions today, but we have to discuss a lot of questions on recursion, and this is the base. So I suppose we have already created a base, and now I'm going to take some doubt from the last session, and I'm going to stop now here, and see. We will going to discuss the doubts in some other session, I suppose. So guys, do you all slept or get very tired or confused with this PMI, principle of mathematical induction, this base case, this assumption, then this task 1, task 2, all those things? Don't worry, we will understand this with the help of the code. We will going to delve deep into it, and the theory is only this much. And this is very important. Whatever I am going to discuss with you right now, principle of mathematical induction, this is, if you should understand this theory, because if you want to enter into the field of this AI, artificial intelligence, machine learning, to this concept, because we are going to use recursion in different ways. There's one concept called I already like memoization, the concept which you will come when you will study the deep learning thing.
Memoization, right?
Memoization.
Yeah.
Memoization is the concept which you are going to study in the deep learning. There, inside that concept, this recursion thing is actually behind this. So you will find the importance of these things in as you move ahead. So if you guys have faced the difficulty in understanding, I strongly suggest you to watch the recorded session once again. at your own pace and try to understand bit by bit. If you ever felt any difficulty in understanding anything, you can drop me a message, you can call me or whatever, you can mail me. Everything is with you. I am here to help you out. So let's end this session today. And now I am going to, after ending this session, I'm going to take your doubts from the previous session. So guys, share me your feedback in the comment section of this video, and whatever things you want to improve, you can also share me that. I will try to improve myself. So hope everything goes well. Good night. Take care. Bye bye. Mm.